All right, part 2 of the little misfit chapter is 3.2. We're solving systems. And good news for you is that 3.3 is super, super easy. It's just calculator stuff. So really the double quiz is just going to be over, or in my opinion, the most difficult parts would be 3.1 and 3.2. And half of 3.2 is something you've already learned in Algebra 1. So I really think it's not going to be too bad. But let's go ahead and get started. And solving systems with just two variables. We're going to look at that first. And that's something you did learn in Algebra 1, using graphing, substitution, or elimination. And then the second half of this lesson is going to be looking at solving with three variables. So when you're actually solving a system of equations, you're trying to find, or the whole goal is finding all the points of intersection. And so your answer will always either be, if you're solving for two variables, it's going to be an ordered pair, so x comma y. And then when we look at three variables, you'll see it's going to be x, y, z. Three variables. So we're starting out with just one. The question is, how many possible points of intersection for two lines? So how many solutions can two lines, how many times can two lines cross? And the answer is 1, they could never cross. So they could never, ever, ever cross, which would be parallel lines. They could cross once, or they could cross an infinite amount of times, which means that they're the same line. So let's look at case number 1 and graph both of these equations. So if I graph negative 2x plus 3, I'm going to put point at positive 3 y-intercept down to over 1. And then x minus 2. Put a point at my y-intercept. My beautiful line. Okay, so this is case number 1 where there's one solution. And the one solution, I didn't draw this super well, but the one solution would be at 2, 0. One solution. They've crossed one time. Okay, if we look at the second one, we have, and I can already kind of see, if you're looking at the slope, okay, they've got the same slope, different y-intercepts. What does that usually indicate? That they are parallel. Line number 1, y-intercept at negative 2. Line number 2. Parallel, so 0 solutions. That only happens whenever you have parallel lines. And then case number 3, if I were to graph this first one, then negative 2x plus 3. Okay, on the second one, it's 2y equals negative 4x plus 6, so I got to divide everything by 2. You'll notice it is, in fact, the same line. So whenever they're the same line, you would say infinite solutions. Now, whenever you're solving something like this, and we're not doing it graphically, we're going to use substitution or elimination. The most common that we see is one solution. If you're solving and you don't have the graph in front of you, and you so you get something like case number 2 where you have no solution, algebraically what that looks like, so no solution algebraically, if I were using substitution or elimination, it ends up becoming like a number equals 0, or or like a number equals another number and they don't work out. Like if it said like 5 equals 4 or 5 equals 0 or something like that, okay, obviously those are not correct. So you end up getting like an incorrect statement. If you have case number 3 algebraically and you have infinite solutions, then you end up with 0 equals 0 or 5 equals 5 or something along those lines. You get a true statement. So a true statement would mean that it is like all of the variables are gone. You're just left with numbers. True statement would be infinite solutions. And then no solution would be a false statement or incorrect. One solution, though, is typically what we see. So in the substitution method, you are going to solve one equation for one variable. You can choose, so you can choose x or you can choose y. Substitute into the other equation and then solve. Once you've solved for that, so let's say you've solved for x, then you're going to substitute and find the other variable. So that's kind of like a step-by-step process, but I like seeing an example better, just in my opinion. So if we look at A, usually what I like to do is find a variable that doesn't have a coefficient attached to it. So for instance, like these all have 2's or 3's next to their variables, but this one is just 1y, 1 in front of it. So whenever I see that, that means I don't have to divide by anything and makes life a little bit easier. So I'm going to solve for y in this equation. If I do that, I end up getting y equals 2x minus 11. And so now that I have what y equals, I'm going to take that and I'm going to plug it in for y here. So 3x plus 2, 2x minus 11 equals 6. And from there, I'm going to solve for x. So I'll let you do that really quickly. And you should end up with x equals 4. You can check my algebra really quickly if you'd like. Once you have that, you're now going to take that x equals 4 and you're going to plug it back into the original y equation. So 2 times 4 minus 11. So y would be 8 minus 11, which would be negative 3. So now I've got my two answers. I want to write this in ordered pair form, which would be 4 comma negative 3. So that's substitution. You solve for one variable, plug it into the other equation, find that and number, so solve for x or solve for y, then go back and plug it into the other one. So I want you to try this next one on your own. Try part B using substitution. And I'm already looking at the two equations and can kind of tell I want to solve for one of them. And if you haven't thought about it yet, I'm going to solve for x on the second equation. Okay, so you should end up, if you substitute for x, you should end up with negative 6y plus 2. Substitute that in to the other equation and end up with y equals negative 1. It actually ended up working out really nicely. Then I take my y and I'm going to plug it back into my x equation, my original, what I substituted. So x equals negative 6 times negative 1 plus 2, which would be 8. So if x equals 8, y equals negative 1, my ordered pair would be 8 comma negative 1. Now the elimination method works, it actually works a lot better whenever you have, like, let's say all of your variables have coefficients in front of them. Sometimes people just prefer elimination. In my head, I like elimination better. It just seems to go a little faster. But the steps for elimination method are you identify which variable has the same coefficient with a different sign. And you may have to multiply to manipulate that to work out. So you may need to multiply. And you may need to be both equations, or it may need to be one or both equations. So even if they don't have the same coefficients, you're at least looking for the same, or like a multiple, like they have a common multiple, like a 2 and a 4, or 4 and an 8, or 3 and 6. Something like that, something where they are multiples of each other and you're able to multiply one of the equations to get to the other one, coefficients. Then you add the equations to eliminate that variable. Then you solve, and then you substitute back in to find the other variable. So if I look at part A, I have x's and y's. They all have the same coefficient, but I want to eliminate the one with different signs. So I'm going to basically, if I look at the y's, one is positive, one is negative. If I add down, then positive y, negative y, those eliminate. If I add the x's, I'm left with 2x. And if I add the numbers, I'm left with 16. The y's have then canceled each other out. They've all been eliminated. So then x equals 8. From there, it doesn't matter which equation you choose. You can choose the top one or the bottom one. And you're going to substitute that 8 back into the original. So let's say I chose the top one. I would have 8 plus y equals 14. So y equals 6. My final answer would be 8, 6. Now if I look at part B, this is an example where none of them have the same coefficient, different sign. So I'm going to need to multiply to get to that point. And if I chose the x's, then I could just multiply this bottom equation. And I want to multiply it by negative 3 so that the 3 and the negative 3 will get eliminated. If you chose the y's, you would have to multiply the top by 3 and the bottom one by negative 2, or the top by negative 3, bottom by positive 2. So I usually like to choose the variable that is, I only have to multiply one equation, but sometimes you don't have a choice, you have to multiply both. So I'm going to come out here, I'm going to rewrite the top one, and then I'm going to rewrite the bottom one when I've multiplied it by 3. So negative 3x minus 9y equals negative 36. Then I add down, the x's get eliminated, and I'm left with negative 7y equals negative 28. Solve for y. I end up with y equals 4. The next step is to substitute this back into any one of the equations. So top or bottom, first or second one. I usually just stick with the first one. So 3x plus 2 times 4 equals 8. So 3x plus 8, whoops. And 3x, if I subtract the 8, I end up with 0. And then I divide 3. 0 divided by anything is just what? 0. So my final answer is 0, 4. Now, some of you may be thinking or being confused about, well, earlier you said if something equals 0, then it makes it a no solution. Or if it's a true statement, it's infinite. If it's a false statement, then it's no solution. That's true when they're both numbers, but this is x equals 0, and that's okay. If you have the variable still left in it, it's whenever all the variables get eliminated, is whenever you have a no solution or an infinite solution. So when they all get eliminated, that's whenever you have one of those instances. And we could go back up to the original equation. If you are still a little stumped about that, you could actually try solving these algebraically, like substitution or elimination. So case number 2, if I use substitution, well, they're both y equals. So then I could just set them equal to each other. Negative 2x plus 3 equals negative 2x minus 2. Because they're both y equals, right? If I solve for x, so I add x to the other side, they end up canceling out. And I get 3 equals negative 2. That's a false statement. It's not right. So that's what I mean by something being a false statement, is that 3 does not equal negative 2. So that would mean that there's no solution. If you did the same thing here, then if I substituted y in here, 2 negative 2x plus 3 equals negative 4x plus 6. Negative 4x plus 6 equals negative 4x plus 6. Try to solve for x. It ends up, everything cancels out. 0 equals 0. Or 6 equals 6 if you didn't move the 6 over. So this is what I mean by a true statement. This would be infinite solutions. All right, let's move on to the second part. I feel pretty confident for you guys for this. So let's go ahead and move on to the second part of the section, and that's solving a system with 3 equations, or 3 variables. So the first thing that you're going to do is I want you to write these steps down, and then I will kind of go, I think it's easier to go through a practice problem, but I want you to have these steps to refer to. So first thing I want you to do is identify and eliminate one variable from 2 equations. So you're going to choose x, y, or z. Or I mean, if the variable is like a, b, or c, you're going to identify maybe 2 that cancel out from 2 equations. Then you will choose 2 different equations. So maybe I did like the first and second and I eliminated x. Now I'm going to look at the second and the third, or the first and the third. So choose 2 different equations and eliminate the same variable. So say for instance I eliminated x completely from all equations. So what you should be left over with is you should be left with now a 2 by 2. So it'll look like now I have 2 variables. So 2 variables should be left. So if you eliminated the x, you should only have a y and a z. Now use substitution, elimination on the 2 by 2 as we've done before. We did in the beginning, or the first half of this section. And then substitute x and y, or substitute y and z back in to solve for the third equation. Back into original to solve for last or eliminated variable. Now, this is something, it seems a little overwhelming, and these notes are not going to really do it justice. You're going to just have to kind of see it and visualize it. But the best advice that I can give you for a problem like this, I think they're really fun. They're really satisfying when you finish it because you've just done a ton of work. But I think that the best way to go about this is to stay really, really, really organized. Like really, 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 really organized. So let's go down to the first example. And I'm going to go ahead and number my equations 1, 2, and 3, just to stay organized. Now, before I start, I'm going to look at x's, y's, and z's, and I'm going to decide which one, in my opinion, would be the easiest to eliminate. Meaning, like, which ones have the same coefficients or multiples of each other. So, I think you can't go wrong with either choosing y or choosing z in this case, because then the z's, like the positive 2z, negative 2z, those can already cancel out, and then you would just take the second one and multiply it by 2. If you chose y, the negative y, positive y would cancel out, and then you would just multiply the second one by 3. So I want you to do the same one as me just for this purpose, but if this were on a test or quiz or something, you could do whichever one you wanted. So I'm going to choose the z's because I just think it might be easier. So automatically, without having to multiply anything, I can take 1 and 3. So remember, the point is to stay really organized. I can take 1 and 3. It doesn't look very pretty. 1 and 3, I'm going to go ahead and write them out. X plus 3y plus 2z equals 5. And then 3x plus y minus 2z equals negative 1. And I'm going to go ahead and combine those because the z's cancel. So if I add down, I have 4x plus 4y equals 4. And I'm going to hold on to this because I'm going to need it here in a second. Then I'm going to choose two different ones. So I've used 1 and 3. Now I have to use 2 and something else. So let's choose 2 and 3. But with number 2, what do you need to multiply the whole thing by to get negative 2z? Or to get positive 2z? You need to multiply it by 2. So I'm going to write this as 4x minus 2y plus 2z equals 16. Keep this one as is. Now I add down, and I have 7x minus y. Z's cancel, and equals positive 15. So now I have done steps 1 and 2. I'm left with these 2 by 2s. I'm going to come over here. Like I said, be organized. 4x plus 4y equals 4. And 7x minus y equals 15. And from here, I now have this 2 by 2 that looks identical to what we did in the first half of the lesson. So I can either use elimination or substitution here and solve for my either x or y. I'm going to solve for y, and I'm just going to go ahead and do elimination again. But I would need to multiply everything by 4. So 28x minus 4y equals 60. And then if I add down, y's cancel. 32x equals 64. So x equals 2. Once you have one of them, You substitute it back into one of the originals, first or second, doesn't matter. So 4 times 2 is 8, plus 4y equals 4. So 4y equals -4. Y equals -1. So I've now accomplished step number 3, which is solving for 2 of the variables. Once you have that, you take your x and your y and you plug it into one of the originals at the very beginning of the problem. It doesn't matter which one. The second one kind of looks like the easiest, just because it seems less daunting. So let's go ahead and plug x and y into the second one, which would be 2 times 2, because we said x is 2, minus -1, minus a negative would be plus 1, plus z equals 8. So 4 plus 1, z equals 8. So z equals 3. My final answer, see, I told you this is really satisfying. My final answer would be in an ordered trio, which would be 2, -1, 3. Okay, let's go ahead and look at the second one. I'm going to go ahead and get you started, but I want you to try it on your own. So let's just look and identify which one we think would be the easiest to eliminate. Right off the bat, I'm looking at the y's, and they all have multiples of 5. So I'm going to go ahead and say eliminating the y's is the easiest. We're going to number these 1, 2, 3. Now I need to choose ones that are opposite signs of each other. So 1 and 3 have opposite signs, and 2 and 3 have opposite signs. So go over here, 1 and 3. I'm going to write these out. And then we said 2 and 3, right? Okay, got you started. I want you to finish it and then check your answer with me. Okay, so some of you maybe got to this point and you were like, well, everything, so the z's eliminated in the second problem too. Well, that just makes life way easier. Maybe you thought, okay, I'm stumped. I promise you this makes life easier. So everything eliminated y's and z's, I'm just left with x. I can actually solve for x in the second problem. Once I have x, I can substitute it into this one. So -6 times -4 plus z equals 22. And then I can actually get z in here. So 24 plus z equals 22. So z ends up being -2. Well, that just kind of took out a step for us because we didn't have to go through the whole substitution elimination thing again like we did on the first problem because two of the variables got eliminated. So now we have x and z, and then we can choose any of them to solve for y. Let's just choose the first one. Makes life easy. So -4x minus, is that a minus or a plus? Minus 5y minus a -2. So plus 2 equals 18. So 16 minus 5y plus 2 equals 18. And it ends up being 0 because the 18s cancel. -5y equals 0. Anything divided by 0 is just 0. So my final answer would be an ordered trio, right? So -4, 0, -2. All right, one more. I want you guys to try this one start to finish. I'm not even going to tell you which variable to use. And I want you to try it start to finish. All right, so I am just looking at it, and I think for me, the easiest variable to eliminate would be z. So I'm going to number these 1, 2, 3. And just by looking at it, if I take number 1 and multiply it by 3, I'm going to get 6x plus 9y minus 3z equals 5. And then 2, which is 4x plus 2y plus 3z equals -1. Z's cancel. And I have 10x plus 11y equals 4. The next two, let's choose 2 and 3. Or you could also do 1 and 3 and just multiply 1 by 6, either one. But if I chose 2 and 3, I'd multiply this one by -2. So I have -8x minus 4y minus 6z equals 2. And then keep the third equation the same. When I add down, you end up with -5x minus 8y equals -17. So at this point, I have these two. I'm going to stack them on top of each other. And then I'm going to use substitution or elimination. My favorite is usually elimination. Oh, that should be a y. And eliminate one variable. Well, 8 and 11 are not really factors of each other. It would take a while. Big multiplying. But I can take the second equation and multiply it by 2. And that would eliminate the x's. So I would have -10x minus 16y equals -34. And the x's will cancel. I have -5y equals -30. So y is going to be +6. Then I take that and I plug it back into one of the originals. So let's just say the top one. 10x plus 11 times 6, which would be 66, equals 4. I'm sure you're like yelling at the screen right now because I made a mistake right here. Ugh. I did not multiply the answer by 3, so that'd be 15, which would then cause this to be 14, which would then cause this to be -20, which would then cause this to be 4, which would then cause this to be 11 times 4 is 44, which would then cause this to be negative. There we go. So x equals -4. So you see, you got to be very organized with this. Make sure that whenever you're multiplying in the beginning, that you multiply everything, even the right side, even the answer. So then I have x and y, and I'm solving for z, so I can choose any of the equations up here. Let's just choose the first one, so 2x, which would be -8, plus 3y, which would be 12, minus z equals 5. be 4 minus z equals 5. So negative z equals negative 1. So positive 1. So z equals negative 1. So my final answer would be in an ordered trio, which would be negative 4, 4, negative 1. So for this lesson, like I said, it's a lot to take in, but I think once you stay organized and you kind of get the hang of it, it gets easier. I do have an extra practice sheet that you guys can work on, especially before you review for your quiz. But like I said, reach out to other teachers, students that are understanding, and hopefully this will start to click. But I hope you guys have a great day, and I miss you all, and I will talk to you guys soon.